In an effort to improve the efficiency and profitability of traditional pond-based catfish production, researchers at Mississippi State University and USDA's Agriculture Research Service have developed what they call a split pond system. In this system, an existing pond is divided into two pond units, one that houses all of the fish and the other that serves as a waste management area. This split pond system addresses several of the inefficiencies of open pond culture and builds on the partitioned aquaculture system technology described in part 1 of this video series. In traditional pond production, fish production, oxygen production, and waste reduction all occur in the same area. But in the split pond system, the fish production area is separated from the oxygen production and waste assimilation area. Researchers have found that catfish can be grown in very high densities as long as the water quality is within near optimal parameters. In most split ponds, the fish growing area is only 15 to 20% of the total pond area, while the waste reduction and oxygen production area makes up 80 to 85% of the total area.
Hello, we're on the Double J Catfish Farm. This particular farm has 8 split ponds and it's stocked exclusively with hybrid catfish. In this particular pond right here, this is actually the first split pond built in Alabama. You have an original, what was a 10-acre pond split into an 8-acre waste cell and a 2-acre fish cell. And this machine running behind me is a water circulator. It's moving water from the fish cell into the waste cell. The aerator was specially designed to turn a little bit slower than a normal paddle wheel and mainly just move water, not make a lot of splash.
The split ponds are constructed by building a levee within the existing pond to create 2 separate cells. This provides a deepened area for concentrating the fish and minimizes the distance the soil must be moved to develop the cross levee. 2 conduits are then built into the cross levee, and a high-volume pump circulates water between the 2 pond cells. Several kinds of conduit and pumps have been used in commercial split ponds. In this particular version, the conduits are open concrete channels, and the pump is a large, slow-turning paddle wheel. Once the cross levee and sluiceways are complete and the paddle wheel is installed, the pond is refilled with water. Steel mesh barriers are put in place on the fish production side of the sluiceways to prevent the fish from moving between the 2 pond cells. During the day, the large, slow-moving paddle wheel pushes water and waste out of the fish cell. This action also brings in oxygenated water from the waste assimilation cell. Running at 2.5 revolutions per minute, a 12-foot paddle wheel that extends 42 inches into the water can move 13,000 gallons per minute and exchange all of the water in the fish culture cell every 2 hours. At night, the paddle wheel circulator stops and standard electric paddle wheel aerators run in the fish cell to maintain optimal oxygen levels. Compared with the traditional 5-acre open pond, it is much easier and more efficient to maintain oxygen levels above 3.5 parts per million in just the smaller fish production area of the split pond. Oxygen sensors in both pond cells work together to control operation of the circulation paddle wheel and aerators. These graphs indicate the daily fluctuation in oxygen levels on both sides. The top graph shows oxygen levels in the fish area of the system. The dotted line represents the minimum acceptable level of dissolved oxygen, and the yellow bars beneath this portion indicate when one or both of the aerators were in use. When the oxygen level drops to 4 parts per million, the first aerator switches on, and if dissolved oxygen declines to 3 parts per million, the second aerator will start. The graph on the bottom shows the oxygen level in the non-fish area of the system. The circulation paddle wheel operates only when the oxygen levels are above 4 parts per million. This occurs generally between the hours of 9 a.m. and 9 p.m. At night, oxygen levels often drop to near zero in the larger non-fish area of the pond, so it's not possible to grow additional filter-feeding fish species, as can be done in some in-pond raceway systems. While some might consider this a limitation, Others believe it simplifies the management process. Research indicates that by using this energy management approach, it is possible to limit the energy cost to 2 or 3 cents per pound of fish produced. Harvesting fish from a split pond system is similar to open pond harvests, but having fish in a smaller area makes it quicker and easier to seine and load the fish. Because there are so many tons of fish in a small pond area, it may be necessary to utilize several live cars to hold the fish prior to loading. Additional aerators are added to ensure adequate oxygen and circulation while the fish await transport. Using a boom and basket, the fish are loaded onto live haul trucks for transport to the processing plant. Production trials in a commercial-scale split pond system have shown that it is possible to grow upwards of 21,000 pounds per acre of hybrid catfish. Researchers have found that the hybrid catfish, which is a cross between a female channel catfish and a male blue catfish, adapt well to these high-density production conditions. Fish survival in all but one of the trials was above 90%, which is much higher than the average 60% survival typical in open ponds. FCR, or feed conversion ratios, were close to 1.8, which is better than the industry average of 2.4. Some of the latest split pond research is focused on selecting the best and most efficient ways to circulate the water between the ponds. Alternatives to the large paddle wheels and concrete sluiceways are being examined to determine if, by using different gear or equipment, construction and operation costs can be reduced. One water movement system involves a propeller inside of a large diameter pipe. The spinning propeller pushes water through the pipe. Another system, designed by David Heikus, uses a smaller, lightweight paddle wheel connected to a corrugated culvert connecting the two cells. Researchers recognize that there are many advantages to this simple and productive system. Lowering the per-pound operating cost and making it easier to feed and harvest fish are also very attractive benefits to farmers. However, the overall economics, dependability, and risks of the system are still being examined, and both groups concede that there is still much work to be done to maximize efficiency and profitability and to reduce risk.